Hi, so this is question 41, and we are going to be doing more problems on definite integrals. And let's look at this particular question. You have to find the integral from 1 to 3 for dx by x plus 1 root over x squared plus x. Now, this is supposed to be equal to root a minus root b, and we have to find a minus b. So, what can we see here? We can obviously see that we can take common here, x common. And if you do that, you'll get something like this, root of x, x plus 1. So this becomes dx by x plus 1 whole power 3 by 2 and root of x, right? Now, this suggests a very simple substitution. Like if I have 1 plus x whole power 3 by 2, I want to use the fact that I can do 1 plus tan square theta whole power 3 by 2, right? If I put x is equal to tan square theta, that works not only for this root, but also for this root tan square theta, right? So if I put x is equal to tan square theta here, my dx becomes 2 tan theta secant square theta d theta. And this is becoming now 2 tan theta secant square theta d theta divided by 1 plus x, which is tan square theta. So secant square theta whole 3 by 2. So that is sec cube theta. And this is root of tan square theta. So that is tan theta, right? So you get cancels, and this becomes sec theta here. And the integral basically is simply 2 cos theta, which is fairly straightforward. Now, you have to change the limits of the integral also, because limits were for x, and now you have changed the variable to theta. So therefore, I will change the limits and I'll say when x is 1 tan square theta, so then theta must be pi by 4. And when x is 3, then tan theta must be equal to root 3. So that is pi by 3. So you can do the integral from pi by 4 to pi by 3, and that will give you 2 sine theta. And you have to evaluate this from pi by 4 to pi by 3, right? So 2 into 1 by root 3 by 2 minus 2 into 1 by root 2. So this becomes root 3 minus root 2. So your a minus b is basically equal to 1, right? So that was pretty straightforward. You had to take x common, and once you get this form, you have to think of the right substitution. The right substitution that handles both of the roots is the tan square theta substitution, right? Let's move on to the next one. Question number 42. This is if integral of 0 to pi by 2 sine power 10x and cos power 10x dx is equal to 2 power minus n 0 to pi by 2 sine power 10x plus cos power 10x dx, then we have to find the value of n. What is n, right? Okay, so how do we go about doing this one? Uh, let's see. Sine power 10x okay. Uh, let's work on this side here, because if we work on this side, we probably get an idea. Like ultimately, what we want to do is, okay, actually here, if you put 2 power 10 here by 2 power 10, we have what? We have 0 to pi by 2, 2 sine x cos x whole power 10 by 2 power 10, right? Okay, so your integral I is equal to this, and which is equal to uh, 2 power minus 10 integral 0 to pi by 2 sine power 10, but 2x is the angle now, right? 2x dx. So if I put 2x is equal to t as my substitution, we get 2 dx is equal to dt. So the integral becomes dt by 2 sine power 10t, and we have the limits of the integral become 0 to pi, 0 to pi, and this is 2 power minus 10. This is my I now. After I have changed the, basically I have changed the variable here, right? This is my I. Now, this we know is equal to twice of 0 to pi by 2 sine power 10t dt by 2, right? And 2 power minus 10 is outside. Why? Because I'm using the property that integral 0 to 2a f of x dx is equal to 2 times 0 to a f of x dx, as long as f of 2a minus x is equal to f of x. I'm using this property here because sine power pi minus t is the same as sine power t. So therefore, we can replace this integral from 0 to pi with double of 0 to pi by 2, and this 2 and this 2 cancels. So we get this is equal to 2 power minus 10, 0 to pi by 2 sine power 10 t dt. And now what I can do is I can apply the property a to b fx dx is equal to a to b f of a plus b minus x dx to convert this integral into a cos integral. So this will become 2 power minus 10, 0 to pi by 2 cos power 10 t dt, because I will apply sine of pi by 2 minus t is equal to cos t. So I have I is equal to this, and I is also equal to this, and I stands for this integral, right? So adding both of them, 2i will be equal to 2 power minus 10, this thing. So you should get 2i is equal to 2 power minus 10, 0 to pi by 2 sine power 10t plus cos power 10t dt, right? Therefore, I is equal to 2 power minus 11, 0 to pi by 2 sine power 10t plus cos power 10t dt. So 11 seems to be the answer for this one. N should be equal to 11. So notice what we did. We started out with an integral which was somewhat like this, right? And this was from 0 to pi by 2. And what we did was we wrote this as 2 power minus 10 sine power 10 of 2x. And then what we did was 0 to pi by 2. We changed the variable, made it 0 to pi sine power 10t, and then changed it again by using a property that it is 0 to pi by 2, 2 times sine power 10t, and then added it to the complementary cos integral and found finally got I, right? So multiple steps, 2, 3 different properties were used, but it was completely doable, not very difficult or anything. Let's move on. One second. Just want to see the question number. Okay, we are on 42. We'll go to question 43. And in this question, we have to apply limit definite integral as the limit of a sum, and we have this expression. We have to actually just find the limit here. So the expression is this: summation r is equal to 1 to 2n n by root over 8n square minus r square multiplied by summation r is equal to 1 to 2n, 1 to 3n this time, n by root over we have to find these three limits. 2 by n tends to 0, so you can write this as 2 1 minus cos 2 by n will be 1 minus cos theta is 2 sine square theta by 2, right? Yeah, so 2 sine square theta by 2 is 1 by n divided by 2 cos square theta by 2 is 1 by n. I'm just using trigonometric identities here, so I'm getting this is equal to tan square 1 by n, right? So for solving this limit, I don't just need tan to go to 0. I need a 1 by n whole square here, right? And therefore I multiply with 1 by n whole square. And I have these two summations, right? So notice what I have done. I've simplified this, made it a tan square. And because the argument of the tan function is going to 0, I need some zeros in the denominator to be able to say that this limit is 1. Limit of x tends to 0, tan x by x is 1. So this limit will be 1. But because I added a 1 by n square in the denominator here, I have to multiply by 1 by n square, which is convenient because I will take 1 by n in one summation and 1 by n in the other summation, right? And once I do that, what I can do is take out this n from here. So now let's handle the summations, right? The summations are pretty easy. You take out n from the root. So n square, you have to divide by n square. And what you get is n by n root over 8 minus r square by n square, summation 1 to 2n r goes to, and there is a 1 by n here, right? Now this thing is actually equal to the integral from 1 to 2 of this n cancels. You have 1 by root over 8 minus x square dx. Now this is basically definite integral as the limit of a sum, and that will be equal to sine inverse x by 2 root 2 evaluated from 1 to 2. So this will be sine inverse 2 by 2 root 2 is 1 by root 2 minus sine inverse 1 by 2 root 2, right? So we get this answer from here. And similarly, we'll get an answer here also. We'll get integral of 1 to 3, 1 by root over 18 minus x square. And that is equal to sine inverse x by 3 root 2. And this time the limits are 1 to 3. So it will become sine inverse 1 by root 2 minus sine inverse 1 by 3 root 2, right? Both of these things are multiplied. So this is pi by 4, pi by 4. These angles are not known. You just multiply them and you'll get the answer, right? Correct. That is this question. Then we move on to question number 44, which talks about the value of the definite integral 2 to 4 for this one, x into 3 minus x, 4 plus x, 6 minus x, 10 minus x, plus sine x dx, right? We have to find the value of this integral. So, okay. So obviously now you notice the limits are weird. It is 2 and 4. So maybe I have to use some property like this. F of x dx should be equal to a to b f of a plus b minus x dx, right? So if this is called I have another version of I, which will be 2 to 4. And this will be 6 minus x everywhere there was an x, right? So we'll get 6 minus x, 3 minus 6 minus x. So we'll get minus 3 plus x. So x minus 3, right? Then we get 4 plus 6 minus x. So 10 minus x. 6 minus 6 minus x. So simply x, and 10 minus x. So 10 minus 6 minus x. So it is 4 plus x plus sine of 6 minus x, right? Okay, we have this integral now. It's also equal to I. If I add both the versions of I should have 2 comma 4. What are the things that are common here and here? We can say 10 minus x common, 3 minus x common, x common, 6 minus x common. Okay, actually it's the same thing except there is a minus sign, right? So if you put a minus sign here, and this will become 3 minus x. You can see the 6 minus x is there, 3 minus x is there, 4 plus x is there, 10 minus x is there, and x is there. So this whole part just cancels out, right? 2i, this algebraic portion just cancels out. And what we have is sine x plus sine of 6 minus x dx, right? And that is a very easy integral to do actually. Like you will just get cos x minus cos of 6 minus x by minus 1, right? And you will have to evaluate that from 2 to 4, right? And you can obtain I here. So notice that the question was designed in such a way that applying this property immediately cancels off this complicated algebraic part, right? So you should think about that property whenever you see some weird situation with weird limits, especially if the limits are a to b and a is not equal to 0 and all. It might be because of this special case or this special property. Okay, the next thing that we look at here is question number 45, where we shall discuss another integral looks like this: tan of ln of x, tan of ln x by 2, and tan of ln 2 divided by x dx. Okay. Now we know that ln x is equal to ln x by 2 into 2, that is ln x by 2 plus ln 2, right? But we have here tan of ln x multiplied by tan of ln x by 2 x by 2. Okay, so I should just basically write this ln x as ln x by 2 plus ln 2, and plus, and that is multiplied with tan ln x by 2 and multiplied with tan ln 2, right? This is the same thing divided by x. Now I can say that this is equal to tan ln x by 2 actually, if you think about it, I should use the identity here. I should say tan of ln x by 2 plus ln 2 should be equal to tan ln x, and this becomes tan ln x by 2 plus tan ln 2 by 1 minus tan ln x by 2 multiplied by tan, this is ln 2 by the way, so tan ln 2. So here you have tan ln x. So now when you cross multiply here, you will realize that you will get tan ln x minus tan ln x tan ln x by 2 and tan ln 2 is equal to tan ln x by 2 plus tan ln 2. So therefore, this quantity that we want to integrate is actually just simply a combination of tan ln x. This is same as tan ln x minus tan ln x by 2 plus, no, minus tan ln 2 divided by x. So tan ln x by x, we can split this into three integrals now. It's fairly straightforward. You say tan ln x by x is 1 and the others are similar. This one tan ln 2 is a constant. So here you will take ln x as t and 1 by x dx will be your dt. You have tan t dt, which is log sec theta. So beyond this point, it is easy. The key trick was this step and this step, these steps, these two steps. Once you get that, you will be easily able to solve this particular problem. Okay, that's all for now. We'll continue with more problems in the next few videos. Stay tuned.